All right. Hello, everyone. Ian just nicely introduced me, so I don't have to repeat much of this here. But what I'll be talking about is modern media transports, rather than my previous talk that was just mentioned, which was about just regular OTT, as in sending things over the internet. Today I'll be speaking about more recent developments, last few years, and last few months even. And I'm going to explain what is new, what isn't new, and why we should care about these things. So first, a quick overview of what is a media transport. A media transport is something that gets media from place A to B. So this can be from server to server. Many transports specialize in this particular use case. But it can also be from server to user, so from someone that is consuming the media. And there are protocols that specialize in that use case specifically. Some do both, some do one of the two, some do neither and do user to user. Today I'll be speaking about these two types. And since VOD is basically just files, VOD meaning video on demand, of course, we're going to talk mostly about live because, well, files is, I mean, some people will probably disagree with me, but let's say that files is a solved problem. So we're going to be talking about live streaming mostly. So there are two main categories of media transports. There's file-based transports and stream-based transports. The file-based transports are mostly segmented protocols, so HLS and Dash, basically. Most of the others that are out there, there are a few others like HESP and a few more, but most of those have kind of gone the way of the dodo, and these are like the two that are left. And those are based on files. They cut up the stream into separate files, and those get sent to users. The other category are stream-based, and they're basically everything else. And these generally do not cut things up into files. They make one connection and they keep streaming continuously. So let's go with the file-based ones first, because there's less of them, so it's easier to explain. And I see that this not render well. Oh well. So these mostly focus on server to user. And they have their biggest influences from browsers. And there are effectively 3 browsers these days, and I'm very sad this didn't render well, but that's supposed to say Chrome, Firefox, Safari. That is supposed to align better. And Chrome and Firefox are easy because they both support MSE, which is media source extensions. This is a technology that lets you take data in JavaScript and just render it in the browser with hardware acceleration. And practically all players out there that work in browsers, they use MSE to render the media. And MSE on both of these browsers effectively supports 2 transports. That's MP4 and MKV, also known as Matroshka or WebM. These are all the same thing. And they will take either of these, and they will let you do whatever you want as long as it's in those 2 formats. So the file-based transports, HLS and Dash, they use mostly MP4 or Matroshka for transport. Now, HLS started out with MPEG-TS rather than using MKV, for example, for legacy reasons that we'll get into on the next slide, or 1 or 2 slides next. But their biggest influence is from those 2 browsers. And Safari, as is seen here, MP4 and TS, rather than MKV. And the reason that they take the influence from there is that if you don't hardware accelerate playback, for example, mobile devices, they will use a lot of battery power, they will heat up, and users don't like when their phone is empty after an hour of watching something. So you want these hardware accelerated and using efficient transports. Is there anything new in these file-based transports? Well, not really. To lower latency, we've created more and smaller segments, and I say we, but that's not me, that's other people. And they've kind of converged in MP4 because Apple was doing TS, but TS only works on iOS, so it's very slow on the other devices, still uses a lot of power. Well, Matroshka is not supported on iOS, so what works everywhere? MP4. So both HLS and Dash have kind of converged on using MP4 segments, FMP4 specifically, but that's just a fancy name for MP4 in smaller pieces. And to decrease the latency, say with LLHLS, they've made smaller segments that they can, request more often. But there's nothing really interesting there. Let's move on to the stream-based transports, where a lot more exciting things are happening. These tend to focus on server to server, most of them anyway. We have the SRT, RIST, and Quic protocols, which most of these are actually relatively old. They're a few years old, but they're getting traction now. So I would say that they are more relevant now. And more focused on server to user are the web-based technologies. You'll see that there's web in front of each of those, which is WebSockets, relatively old. This was standardized in like the early 2010s. WebRTC, which is like late 2010s, and Web Transport, which is just barely standardized now, like it was standardized a couple months ago. And because these work in browsers, they tend to be focused more on going towards users rather than servers, while those three don't work in browsers. I should mention that Quic is actually the basis for HTTP3, so it does technically work in browsers, but you don't get access to the direct Quic protocol, and server-to-server you do. So that's why I'm making that distinction here, not putting it in the lower list. And I'm going to go into each of these separately. I say each, but I'm actually going to skip WebSockets and WebRTC because they're old and old-ish. I consider those not modern anymore. I mean, they are, but not as modern. Is there anything new in these either? Not really. I will go into detail on the next few slides, but all of them effectively do retransmissions, forward error correction, and adaptive bitrate. And retransmissions means that if a packet is missed during network transport, it is either automatically or semi-automatically retransmitted so that you can make up the missing data. Forward error correction means that you send more data than is necessary so you can calculate missing data. It's another technique to handle packet loss. And adaptive bitrate is that if the amount of data transferred over a network connection is more than the connection between A and B can handle, you will automatically lower it to match. These are all fairly old technologies, actually, but it is new that they're all being combined into protocols. A quick refresher on networking in general. TCP and UDP are the two main things that go over the internet. Everything is either one of these two. I say everything, but it's like really like 99.99 several nines %. TCP is what most of the internet uses today. It's reliable, but however it can be slow, especially when network connections go bad. Then TCP can really grind to a halt. Well, UDP is really, really fast, but it has the disadvantage it can be unreliable. If network connections go bad, UDP will just not receive packets for some time, and then after that immediately recover, but you'll have missed a whole chunk of data. And if you're sending something like a video stream, it's kind of bad to be missing a whole part. So you want to compensate for that. And what these modern protocols have done is they've all kind of thought, gee, that TCP thing that it's reliable is nice. We want that, but we want that speed of UDP. So what they're doing is they're using UDP to try and improve TCP and make like a better version of it. Like call it a TCP 2 or 3 or whatever you want to call it. And there are several companies that are working on technologies that think they can do better than TCP. And the first of these is SRT, which was made by Haivision. It's their attempt at a better TCP. I would call this a useful standardization of old and existing technologies, because again, they all do those things from the previous slides. SRT is UDT based. UDT stands for UDP Data Transport, if I'm not mistaken, which is basically UDP with retransmissions. This is an older standard from like the 2012s that came out of some, I think, Chicago University research. And Haivision thought, okay, let's build on top of that and add some extra things, especially for streaming, because UDT was really made for transferring big data sets between universities. So it adds those streaming-related connection properties, and it adds forward error correction. That's what FEC stands for, forward error correction. But the forward error correction is an optional feature. It's not on by default if you're using SRT. It also optionally adds bonding, and bonding means that when you have multiple network connections, let's say a 5G connection and a Wi-Fi connection, or maybe a fiber connection and a satellite connection, and they have different properties, you can send some of the data over one, some over the other, and they will kind of add up to a whole stream. This too is optional in SRT. It's not on by default, but you can do it. And I should note that only the very latest versions of SRT do this quite well. The older ones, it's not really there yet. SRT is, in principle, content agnostic. You can send whatever you want over an SRT feed. It is a pipe, so to speak. But in practice, everyone really sends MPEG-2 over it. There is a newer spec that is being pushed by the Eurovision guys that does MPEG-TS over RTP with error correction, but it is still MPEG-TS underneath. So I'm going to just simplify it to it's always MPEG-TS based. And this is a little sad because MPEG-TS is ancient technology. This is tech from the last century rather than the 2000s. And it is a technology that was made for radio networks, when broadcast still meant having an antenna. and it can handle loss of packets really well, which is why these protocols that use UDP tend to standardize on MPEG-TS, because it was made for having a bad connection occasionally. But it's also very high in overhead, and these fancy new protocols, they can usually correct for whatever loss you have already, so they don't need that extra layer, but it's there. So, existing tech, nothing really exciting, but it's a new combination, and it's useful that it's now standardized in a way that everyone can kind of agree, okay, we're going to use this COMO and call it SRT. What else do we have? So RIST is the attempt at a better TCP by the VSF organization, which is a group of multiple companies working together to standardize video-related standards. It's basically the same thing, a useful standardization of existing technologies. This one is not based on UDT, it's based on RTP. RTP is also known because WebRTC is based on RTP as well, specifically a secure variant. And the good old SIP standard, which is internet telephony, is also based on RTP. So it's kind of a good old reliable spec that has been in use for a long time. It adds support for retransmissions, just like SRT did. It adds support for forward error correction, again optional, and again just like SRT did. And it also adds support for bonding. So it's kind of the same thing, except a different underlying technology. RIST itself is also contact agnostic. It sends packets over RTP, and this is kind of exciting. It was to me at least when I saw it, because RTP can do almost any media. You don't have to send a particular type. You can send almost anything. You could send AV1 over that directly. But in reality, it always uses MPEG-TS over RTP, which is making me sad for the same reasons the last slide made me sad. So that means that it is effectively the same thing. Just different names, slightly different specs, slightly different standards, but it's all the same technology and all the same combinations. That brings us to Quic. Quic is Google's attempt at a better TCP. It has been much more successful in terms of market uptake because it is not streaming related at all. It is actually a generic TCP replacement. Some people call this TCP2. And Google is mostly pushing this for doing HTTP, just web browsing. And practically every connection that anyone makes to Google servers is actually running over Quic, specifically over HTTP3, what it is the basis for. And HTTP3 is the UDP version of HTTP, which, in case people here don't know, I hope most people know this, HTTP is the spec that lets you view web pages. So because it is very generic, it is not great for streaming by itself. There is a media-specific extension, which is MLQT, which media something something quick transport. Media over quick transport, there we go, that's what it was. That's a media-specific extension to Quic, so something on top of it, but it is still kind of work in progress. You can look up the standardization spec for it already, but it's not finalized. It's still in the process of being formed. It's getting along there though, but in the meanwhile, many companies are doing something custom over Quic. And this lets them be a little bit ahead of the curve at the disadvantage of not being standardized. Which brings us to web transport, which is also on top of Quic, because you guys might be familiar with WebSockets. It's a standard that lets you make HTTP connections and go bidirectional. And it is very common, especially in the last few years, to make a connection to a web server, send media over it, and then use MSE, for example, which I covered in previous slides, to turn that into a media stream. However, WebSockets are TCP-based, so they're relatively slow but reliable. Web transport is the fancy new version that just a couple months ago was finally finalized. And this does HTTP3 WebSocket alikes, but it has a big difference compared to just being, WebSocket's new. No, it also does lossy transmission, which means that you can have UDP behavior in browsers. And that's kind of a first, because the only thing that ever lets you do that is data channels on WebRTC. And this lets you finally do lossy transmission using more normal JavaScript-based things. Unfortunately, however, Apple has decided not to support it yet. I mean, no one can predict what they will and will not do. Which means that you have to fall back to either WebRTC or HLS for them, but hopefully in the future. For everything that's not Apple, though, web transport will get you really low latency streaming, and this is theoretically possible today already. You just need a simple web-based player. It won't work on anything that's not a browser, though, so that's unfortunate. So what's the conclusion here? Nothing is truly new in recent developments. The combinations and use it patterns are. But yeah, it's kind of all the same stuff being rehashed over and over, which is kind of a theme in the video industry, I guess. Of course, if you want to keep up developments as they happen, my team, the MistServer team, can definitely help with that. We're over there at booth 5F43, short stroll away. You can chat with me or some of my team members that might be hanging around. If not, they're short stroll away. Or you can send an email to us or visit our website. It's that one, either .com or .org. And we'll help you do whatever you need.